Hello everyone, my name is Tom, and in this presentation I will demonstrate the pre-processing steps of our OCR pipeline. So after the user has taken a photo of a receipt, the image is sent to our microservice. Then the first step of our microservice is receipt segmentation. This means that the image is sent through a specialized deep neural network which labels which pixels in the image belong to a receipt and which do not. And the result of this segmentation you can see here on the image on the right. Then the second step of the pipeline is to then draw the smallest possible bounding rectangle around the pixels classified as belonging to a receipt. Again, you can see the result of this by looking at this green rectangle on the image on the right. And then the third step is to crop the image or cut it out and also rotate it such that it's oriented correctly. However, we've found that this step doesn't always work perfectly, especially when pictures of images are made upside down. So we do suggest that we add some type of indicator in the app's user interface such that the user can help us identify the correct side up of the receipt. So for example, something you can see here on the image. Finally, I want to mention that we've tested several different OCR models, and we have also combined those models with a variety of pre-processing techniques. And though it would be quite desirable to find pre-processing techniques to enhance our OCR result, especially as those will be easily generalizable across different countries, we've unfortunately found that, well, with the OCR model that we are currently using, that these steps do not improve the results according to our benchmarks. And as such, we've concluded that our best performing OCR model is better at separating signal from noise than these types of steps can in sort of specialized pre-processing steps. Finally, I want to show some code in action to give a little bit of an idea of what actually happens. So here you can see those steps that I just mentioned. So this is the input image, then it's segmented and the bounding rectangle is drawn. And finally the image is oriented upright, and that's so you see 3 images per receipt, so the input, then the bounding rectangle and the segmented image, and the final output. And so I just ran this code for 5 receipts, and you can see it's finished in like 2 seconds, so it runs quite quickly. And you can see that the results are typically quite good. So we've tested this on about 500 receipts, and it works quite well, as in that it successfully cuts out a lot of the background noise, and it doesn't cut out anything of the receipt. So this is basically the result of our pre-processing step, and those lost images, you can see here the 3rd images per receipt, and those will be the input for our OCR models, and Tim will now say a little bit more about those.